Hello everyone, this is a video lecture for PreCal Chapter 2.8, and we're going to be focusing on inverses. Let me just give you a quick tutorial, reminder, refresher on all of this, a review. So inverses are like graphs, let's say, that can be symmetric about the y equals x line. So let's say this is y equals square root of x. Well, this is y equals x squared. See, they're inverses of one another. And you can see graphically about this y equals x line. It's basically like the 45-degree line. That they're symmetric about that. They're the same, I guess you can say, if you were to flip it on the other side of that 45-degree line. Notice that we have the x squared and the square root. Square and square root are opposites of one another. We're looking for opposites, and I'm going to be using that word myself a lot because it's helpful in English to think like that. When I say opposite, I say plus 2, you say minus 2. If I say like times 3, you say divide by 3, and that's exactly what's going on. You got plus and minus, they're opposites. Multiply, divide, those are opposites. And then power and root. I'm just using the caret symbol for that. But power and root are opposites of one another as well. And if you kind of remember, this is just a trivia. This actually has a 2 right there. You know how we have like the cube root and the fourth root and stuff? Well, the square root, we leave it alone. Well, basically, technically, there's a 2 there. There's an invisible 2. So then you could see that's 2 and 2, 3 and 3, etc. Okay, so that's kind of like the overview, kind of like reminding you of what these inverses are. I'm going to now just do a quick example or two to just, I guess, the long way, just to make sure that we're all okay. Let's just say, here's my example. Let's say that I have y equals x cubed. And I'm like, okay, well, what's the inverse? What's the inverse equal to? Well, I'm going to use this thing called switch x and y. And we're going to be using that on some other problems later. But wherever you see a y, now you put an x. Wherever you see an x, now you put a y. Cool. Well, I mean, if we were to just, somehow be able to say that's the answer, it would be good. But we have to solve for y. Because they're wanting a function, a single y. And so I'm saying, okay, I want y by itself. What am I supposed to do? Well, I'm going to cube root both of these guys. Of course, these guys cancel. So I got y is equal to the cube root of x. And that's your inverse right there. There you go. We label it as f inverse of x. F inverse of x. If, let's say, this was just f of x right here. Cool. That's it. That's how you do it. So we already saw the opposites here, cube root. But let me do another example or two, and I'll show you just some other ways, the long way, I guess you can say. So here's just another example. Let's say that I started with y equals 2x plus 3. That's a pretty basic one. So what's the inverse? Well, I'm going to switch my x and y, and then I'm going to solve for y. So minus 3 on both sides. Divide by the 2 on both sides. So I got y is equal to x minus 3 all over 2. That's my inverse right there. Okay. Oh, no question mark. That is my inverse. Okay. Just real quick though, let's talk about this. Is there a way to go from here to there immediately without having to do the switch and the long way and all that stuff? Well, yeah. I mean, you're just looking at opposites. So you're multiplying by a 2. Now you're dividing by a 2. All right, that's not too bad. You're adding a 3. Now you're minusing a 3. See how they're opposites? But here's the other one that some people don't often think about. Notice that the 2 is only with the x, but now the 2 is for the whole thing. Okay? Kind of like inside, outside kind of stuff. The 3, it's just, 3 is by himself. He's just, 2x plus 3. So now we have the 3 is on the inside with the x, and then all divided by 2. So there's opposites even in their relationship to one another, not just their operator, but also their relationship, where they are in the function, okay? And so there's a lot of ways to do this opposite stuff. There's other tricks, but I just wanted to show you and remind you that there's ways to do this other than just the long way to make it work. So let's do some actual problems from the homework now. So some of these are like super easy. Some are kind of confusing about what they're wanting, but that's why we're doing them here together. So I have a 0.19, and they say, where would the inverse be? Inverse. Where would that inverse be? Well, I'm not kidding you. They have this parentheses box thing here. You're just going to put 9, 1. I'm not kidding you. That's what it is. Because what did you do to find the inverse? Well, you switched x and y, didn't you? This was x and that was y. You switched them. See? That's what we were doing way up above on those other problems. Like, graphically, let me kind of just show you what's going on here. Let's just say, just an example here. Let's say I had 2, 3. This is about right there. So that's 2, 3. Well, then what would be the inverse of this guy? Well, it's 3, 2. 3, 2. Notice how they're opposite of one another along, again, that 45-degree line. Like if I had a graph that did this, well, then its opposite would do that. I mean, they're inverses. They're opposites of one another. They're symmetric about that y equals x line. Okay. That was just another example, not really part of that problem there. 2.8.017. It says h of x is equal to x squared minus 6x, and then h inverse of x is equal to what? Now, just hold on right quick. We've already done some examples on how to find the inverse. They're saying h, not f. Doesn't really matter. Basically, I'm going to rewrite this as a y, and then I'm going to switch my x and y, okay? So remember, everywhere you see on x, you put a y. Everywhere you see y, you put an x. Everywhere. Now I know, look, got 2 different y's. It kind of scares me. In some problems, that's a bad thing. Sometimes it's a good thing. I think in here it's actually a bad thing. I'm going to factor a y out, just trying to simplify it a little bit. But notice that there's no good way to get my goal. I'm going to show you my goal here. My goal is y equals blah, 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 blah. Okay? With a lot of x's and stuff. X's and numbers and stuff like that. There's no way to get y by itself. Look, there's a single y. That's it. But here, I got 2 of them. You're thinking divide or square root or whatever. Try it. It's not going to work. You're not going to be able to get y equals and just x's. So I'm going to say no inverse. Like, what do you put up here? And that's funny. There might be a button that you just click. It says no inverse or something like that. Sometimes they'll say in the text, they'll say, like, if there's no inverse, put none or something like that in the box. Another common one that is used in WebAssign is DNE. DNE. Okay? I don't know what they're wanting in this particular case. I can't remember. I don't have it written down. But it's no inverse. We know the math. Now, how do you put that into WebAssign? They should explain it to you in the directions, okay? But if not, try none, DNE, or just click something maybe, that kind of stuff, okay? Some other language that they'll use whenever you have no inverse, they're also going to be using this not 1-to-1, okay? Now, what they're trying to say here is no inverse. That's what they're really trying to get at. You have to have a set of points that are 1-to-1 in order to have an inverse possible. Blah, blah, blah. It's just another way to say no inverse, okay? So if you have 1-to-1, then you could have an inverse, okay? All right, keep moving. 2.8.029. This graph's a little weird. It kind of does this thing like this. And I think at this point we have a 5 and a 3 right there. Yes, that's good. And this is F. They say this is F. What they're wanting is F inverse of 3. Now, this is kind of strange. Inverses are opposites or go backwards, I guess is another kind of way to say that. Opposite, backwards, that kind of stuff. So what you're doing, you're starting at the 3, and then you actually go down to find your x. This is actually an x right here. 5. I mean, but here's the thing. Looking at this thing, you have these two numbers. There's no way you can put another number in there as far as like what I'm seeing. Maybe you have a grid. Maybe there's a lot more numbers. I don't know. But it seems pretty obvious. You start with 3, you go and find your other number. And in this case, it's 5. So it's kind of a weird thing there, but, you know, it works. Okay. Let me tell you a little bit why. So normally, let's say normally, I'll write that down. Normally, we have y equals f of x. Have you seen that before? Y equals f of x. This is like the standard algebra function stuff. Okay, so I've been assuming that you at least know that a little bit. That's normally. The inverse actually looks like x equals f inverse of y. Now, often we say x like that. We say f inverse x, and we put a lot of x's and stuff like that. That's fine. That's another way to express it. But if you were to say these are equal to one another, how would you have to express it? Well, it would be this. You're switching your x and your y. And so your y is the input, where you start. And your x is the output, where you end. So that's why it's your output, your end. Okay? Just some memory tools, I guess you can say. Keep cruising. 2.8.038. So I have f of x is equal to 6x. G of x is equal to x over 6. And they say, are these inverses? Are these inverses? Well, yes. You just look at them. Multiplying by 6, dividing by 6. The end. But to check it, to double check it, you would have to do f of f inverse of x, and it must result in an x. And just an x. Nothing else. Must result in just an x. And then they would be inverses. And so what we're going to be doing is f of g of x. And so you can see that what I'm going to do is take this and toss it in there. 6's cancel. There you go. So yes, check. Yes. Obviously you did not have to do that. You can kind of just look at it and say, oh yeah, look, opposites, inverses. Next one, f of x is equal to 2 minus 8x. G of x is equal to 2 minus x over 8. Now, a lot of my little tricks, I guess you can say, for opposites kind of fall apart whenever I have a minus sign in front of the x, or something's kind of mixed up or something like that. So I get confused real fast about this. But let's just look at them with our human eyes and see what we can do about comparing them. Notice that we got a 2 and a 2. Notice that we have a multiply by 8, divide by 8. Yeah. It's funny because this 8 is only with the x, but now 8 is like for everybody. Okay? Now, I know the minus sign did not turn into a plus sign, but it also was attached to the x and not the 2. Kind of funny how that works. So I'm kind of on the fence. I'm saying, are they inverses? I would say, I don't know. I mean, they're close. It might be. So this is a good opportunity to actually do this f of g of x, this f inverse of x. So we're going to do this test and see if we get x out of it, okay? So I'm going to take this and plug it in there. I'm going to shove it inside. Just like that. Okay. Well, can I start simplifying it? Like, well, actually these 8s will cancel. Distribute your minus sign. 2 negatives make a positive. These guys cancel. Look, we got just x. So yes, they are inverses. And you would just say yes. Now, again, I'm trying to remember exactly how these problems work. If you actually have to type the x in for your answer or not, I can't really remember. But let's just say on the homework that you had 2 options. And this happens sometime. It might not be this question. It might be others. You would say yes, inverses, or no, not inverses. Something like that. Let's just say that this is how this answer is styled. Well, let's just say that you click the yes button and you submit. You're just guessing. And it says, yay, you're great. That was easy. But what if it said, no, you're wrong? Well, then you still got 3 attempts or 2 attempts or whatever it is. Well, you check this and you hit submit. And it's either this one or that one. And you have 2 options, but you have 3 or 5 attempts. I can't remember what we have in this class. Attempts. You do the math. You're always going to get it right. You can go through the whole section and not do a single piece of math. You just click, nope, click, yep, click, yep, click, nope, click, yep. It's that simple. Just saying. Again, I'm not trying to tell you how to cheat. That's not what we're doing here. I'm just saying learn the program. Learn its limitations. Do you think your exam's going to be this way? I mean, maybe. But you only get 1 attempt on the exam. And so when you go in and you hit that 1 attempt and you get it wrong, that's wrong. So you still need to do the math. You still need to learn it. But I'm just saying this should not be a hurdle. This should be help. Okay, keep going. F of x is equal to x over x plus 6. And they want the inverse for this guy. Like type it out kind of thing. I'm telling you, this one is weird. I mean, we got a plus 6, maybe we got a minus 6 now. I don't really know. Like, I'm just confused, and that's why I'm doing this one with you. If it were the easy ones, I just, I wouldn't want to do all the easy ones and leave the hard ones for you. So I'm going to rewrite it with a y, and then I'm going to switch x and y around. Okay, now I got 2 y's, and that makes me really nervous. Normally I would just want to quit. But let's just keep going, okay? Let's just see. So solve for y. Let's do some math and see what I do. I'm going to multiply this to the other side. Like, how can I make this simpler? Well, get more simple? Either way. I'm going to multiply that denominator to the other side. I know that sounds weird, but look, I don't have any more fractions. Like, seriously, do you want a fraction? Do you want to keep on working with a fraction? No. Get rid of the fraction. Move it over. That way it's a little bit more simplified. Distribute your x. Seems like an obvious step to do. And now let's just pause. I'm looking at this, I'm thinking, well, what's my next step? What should I do? Like, well, remember that your goal is always that you want to get y equals blah, 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 with a lot of x's. You want to get y by itself. And so, how do I do that? Well, what if I minus y on both sides? And then what if I move this x over? Now let's think about it for a second. Do I have y's on one side? Yes. But I still got 2 of them. So if I could factor this out to the front, remember that's a 1 right there. That's a 1y, 1. Take this, divide it, and that's your inverse. You did it. You're done. There it is. Does this have any... Ooh, I got a negative here? I have a positive on my answer. Don't know why. Oh, I see why. Because I flipped the bottom. Okay, never mind. Yeah, this is good. Another version of this that I have on my paper is this guy. WebAssign does not care. They don't care. Both are fine. Both are equivalent. Notice that my denominator's flipped, and that's why I can have a different sign on the top. Either one is fine, okay? So there you go. Cool. We did it. I got 2 more problems. And then we're done. I think this is going to be an easier and smaller section than the last time. Plus, I'm not talking as much. Hopefully, g of x is equal to the square root of x plus 5. And they say, find the inverse. Now, what I did here, just between you and me, I just guessed. And I guessed good. So, here we go. It's x squared minus 5. Let's just pause. I can go back and just say, well, y equals the square root, switch x and y, start solving. Yeah. But I want to prove a point here. I want to prove a point that you don't have to always do that. There are times when it's pretty darn necessary. I'm looking at that last question, I wouldn't know. But this one here is easier. Look, I got a square root, so square. I have a plus 5, I got a minus 5. I would have had the square root for the whole thing. Now square is only just for x. That's it, just for x. Opposites in every way. That's it. I can't remember if they want a graph here or not, but I'm going to show you right quick. So that graph would look something kind of like, I'm just guessing here, there's my square root, there's my square, and there's my 45-degree line. Something like that. I can't remember if that was actually part of the problem or not. I just have it on my paper. Okay, last question I have is this. F is equal to 9 over 5c plus 32. C equals what? Now, what they're actually wanting here is the formula from Fahrenheit to Celsius. Now, I cannot spell either one of those names. So, Fahrenheit to Celsius. Well, now they're wanting Celsius in terms of Fahrenheit. Do you know how to get this answer? No, not that way. It's DuckDuckGo, of course. You could search for it and just get the answer. What's the formula for finding Celsius in terms of Fahrenheit? You know, conversion formula. Yeah, and you would find it. Let me just give it to you, I guess. We got a 5 times f minus 32 all divided by 9. And there we go. There's your answer. Now, could you do this with the switch x and y and all that kind of stuff? Well, yeah. I just wanted to show you the funny way to go about doing it. But let's just say if you were switching it, I wouldn't actually switch here. Because notice that my f is on the other side. We're just solving for c. That's really all you're doing here. So in order to do that, move the 32 over. And then you're going to multiply, divide. You're going to move it to the other side, whatever. That's 5/9. And you can see that mine's equivalent to that one. There you go. That's it. That's all I got for this section. Let me just double check. Yep, that's it. So thank you very much, and have a great day.